Hello, today we're talking about mechanical advantage. We've been looking at a variety of different types of simple machines, and it's important to know how to calculate the advantage that that machine gives you when you use it. So we're going to use the guess method to solve these problems. In order to solve these problems, we have to remember that there are certain types of measurement that we will be using, the variables that you'll find for those measurements in any equation that you see, the units for those measurements, and the unit abbreviation. First one is length. If you see the term length in any equation, it's going to be written with a lowercase l. The units for length are meters or centimeters for any of these problems that we're doing. And the abbreviation for meter and centimeter is either lowercase m or lowercase cm. Another type of measurement that you might see in these equations is the radius. Radius is abbreviated or is a variable as lowercase r. This is also a unit of length. When you measure the radius of a circle from the center point to the outside edge, then you measure that either in centimeters or meters. Height is another variable that you might see. That variable is lowercase h. And again, this would also be in meters or centimeters. Force is another type of measurement that you might use when you're calculating mechanical advantage. Force is a capital F in an equation. It's measured in newtons, and the abbreviation for newton is a capital N. Finally, we are also taking a look at mechanical advantage. The variable for mechanical advantage is capital M, capital A, and it does not have any units. So let's take a look at some equations. What does the mechanical advantage of a machine tell us? Why are we calculating this? Well, mechanical advantage tells you how helpful the machine is. That's another way of saying how many times the input force, which is the force you apply, is multiplied by the machine you're using. It's important to remember, input, in this case input force, is the same as the effort. That's what you apply to the machine. So if you were using a pulley to lift a box, the amount of force that you use to pull on the rope is the input force or the effort force. The other type of force is the output force. This is also known as the resistance. This is what the machine does to the object that you're moving. So if you think of that same pulley pulling on, being used to lift a box, the force that the pulley uses to pull on the box is the output force or the resistance force. In order to solve these problems, you need to know the equations that are being used for mechanical advantage, and they're different depending on the different types of simple machines that you are calculating for. I would highly recommend you get a pencil and paper, copy these equations down so you have them handy while you're working on the assignment part of this presentation. The first equation is MA equals FO divided by FI. FO divided by FI stands for output force divided by input force. Just a note here. Why do we write it like this? This is written as force because that's what you're actually measuring, but we have a subscript to tell you what kind of force. In this case, it's the output. So you see capital F subscript O, or for this one, capital F for force, I for input. Another equation you might need is input length divided by output length. Both of these can be used for pulleys or levers. Another equation that you might need is the radius of the input divided by the radius of the output, otherwise known as radius of the wheel divided by radius of the axle. So obviously this would be for calculating the mechanical advantage of a wheel and axle. And finally, the length of the ramp divided by the height of the ramp. This would be used for calculating an inclined plane. Oops. So there we have the equations that you might need to use in order to complete your assignment. These are also found on these pages in your textbook. So basically pages 160, 161, and 162 if you need to go back to that. Okay, now let's do some practice problems. This practice problem says, what's the mechanical advantage of the wheel and axle? Here you see an outside faucet, and the handle of that outside faucet is a wheel and axle. Sorry, let me get my pen here. This says that this wheel and axle has the wheel of a radius, or with a radius of 45 centimeters, and the axle has a radius of 9 centimeters. The axle would be this part right here, and the wheel is obviously the handle part that you turn. So let's put that into a guess problem. We said that the radius of the wheel is 45 centimeters, and the radius of the axle is 9 centimeters. That's the given information. The unknown, what we're searching for in this problem, is the mechanical advantage of the wheel and axle. The equation for this particular type of simple machine is radius of the wheel divided by radius of the axle. So if we plug that in, remember you have to make sure that the correct things are in the numerator and the denominator of your fraction. This says 45 centimeters divided by 9 centimeters. And that gives you a mechanical advantage of 5 for this wheel and axle. Very good. Okay, let's move on. Now we have a lever. This says that Mr. W is applying 20 newtons of force to this lever, and the lever is applying 80 newtons of force to the box. What's the mechanical advantage of the lever? So if we take that and look at the picture, this says that 20 newtons of force is being applied by Mr. W, and 80 newtons of force is being applied by the lever to the box. That must mean we're looking at forces. We have an input force and we have an output force. The input force is what Mr. W does, so that is 20 newtons. The output force is what the lever does to the object, so that would be 80 newtons. Now let's put this into a guess problem. We have input force and we have output force. Input force is 20 newtons. Output force is 80 newtons. The unknown is the mechanical advantage of the lever. The equation for this type of mechanical advantage is output force divided by input force. When you substitute, make sure the correct term goes in the numerator. So this we need the output force. So we're looking at 80 newtons divided by 20 newtons. So the mechanical advantage of this lever is 4. Good. Let's continue. Now we know that the length of the lever from Mr. W's hands to the fulcrum is 20 decimeters, and the length from the fulcrum to the box is 5 decimeters. So from here to here, here's the fulcrum. So the problem says that from his hands to the fulcrum is 20 decimeters. Would that be the input or the output? From the fulcrum to the box is 5 decimeters. Now we're talking about lengths. So we have output length and we have input length. The output is what the machine does to the box, so that would be 5 decimeters. The input length is where the person is applying a force, so this would be 20 decimeters. Now let's plug this into our guess problems. We're given 2 lengths, input length and output length. Output is 5 decimeters, input is 20 decimeters. The unknown is still mechanical advantage. The equation for this type of mechanical advantage is input length divided by output length. Notice it's backwards from force. Force was output divided by input, but when you're talking about lengths, it's input divided by output. That's why having those equations right in front of you is really handy, because sometimes they're easy to mix up. So make sure the correct number is in the numerator. So we have numerator needs to be 20 decimeters divided by 5 decimeters. And 20 divided by 5 is 4. So if it's the same lever, same object you're moving, same person applying the force, the mechanical advantage, no matter which way you figure it out, is the same. You can figure out the mechanical advantage using length, or you can figure out the mechanical advantage using force, and it comes out to the same mechanical advantage. Very good. If you have any questions about this, please make sure you let me know.